This is the review for the multiple choice part of the Algebra 2 final exam in spring of 2018. I have made a few changes to the original document, so if you're watching this from a different classroom than mine, just remember that some of these problems have been changed from what your teacher gave you. So here we're going to subtract these polynomials, and I would suggest that you distribute the subtraction all the way through and rewrite the question itself. So x squared plus 5x minus 7 minus 3x to the third minus 6x, but this last 7 here becomes a positive 7. So then you're going to want to collect your like terms. The answers in multiple choice will always be in standard form order. So negative 3x to the third will come first, and then there's plus x squared. You're going to need to combine 5x and negative 6x, so that's minus 1x, and then plus 7 minus 7 will cancel. So there's our answer there, and please do be careful on multiple choice questions like that. Very easy to mess up, and all the answers are designed to trick you, basically. So profit function is revenue minus cost. So essentially it's the same concept of subtracting two functions. You just have to be careful that you're doing it properly. So the revenue function is 3.5x, I see that right here. And then you're going to be subtracting the cost function, which is 0.55x plus 15. But we just learned in the last question we have to remember to subtract all the way through the second polynomial. So 3.5x minus 0.55x is 2.95x, and then this becomes a subtract 15. Most common mistake is the child who does not distribute the negative to the 15, and then they put a plus 15, and I guarantee that'll be an answer choice. I'm going to skip over to number 8 and 9 since they're on my screen. Number 8 says, what is the remainder when you divide these two polynomials? So it's your choice. You could do synthetic or long division, but most of you like synthetic better. So in the box, you do the opposite sign of the solution to that factor, so it's positive 3. And then you line up your coefficients in standard form order and make sure nothing is missing, because if they are, you got to put a 0. So we have 3, negative 13, positive 18, and negative 18. So the way, oops, I needed a little space there, that was my bad. The way this starts off is you bring down the first coefficient, and then you do a series of multiplications and adds. So 3 times 3 is 9. And then add these up and you get negative 4. Negative 4 times 3 is negative 12. Add these up and you get a 6. 6 times 3 is 18. And this is one of those questions where it turns out the remainder is 0, and that's what they want. The last number is your remainder, and ours came out to 0.
Mr. Savage, can you please call me office? Mr. Savage?
Number 9 says, please do use synthetic division. Again, it's multiple choice, so you can really do whatever you want. But everyone loves synthetic division better. In the box, we put the solution to that factor, so negative 2. Be careful on this one, though. We are missing a quadratic term, so the coefficients are 1, 0, negative 14, and 8. Alright, so running through synthetic division, start by bringing down your first coefficient, and then again it's a series of multiply-add. So we're going to multiply, get negative 2, add them up, get negative 2. Multiply again, 4, add them up, get negative 10. Multiply again, you get 20. And this is a 28. So remember, the last number you get in synthetic division is your remainder. So when I have to go write my answer, this is the body of the polynomial that's your resulting quotient, and you have to attach the correct variables to it. So you started with a cubic, and you divided by a linear, so what you have left is a quadratic. So this is 1x squared, and then go down the line, minus 2x, minus 10, and then the remainder is written as a fraction. It's remaining in the division question, so it's still being divided by that x plus 2. This is your final quotient. Again, going to be multiple choice, so we'll figure it out. Back to number 3 now. We have two functions, and we're going to ask you to multiply f times g. So anytime you have a polynomial and you're distributing, it's a very large and in charge. You guys used to call this a FOIL problem, but it's a distribution question. So 3x minus 3, this is not that big of a question, actually. I thought it was a cubic for a minute, but it's not. And we're just going to distribute. So 3x times x is 3x squared. 3x times 5 is plus 15x. Negative 3x next. And then minus 15. I think one of our major issues in Algebra 2 is sometimes just stressing out a little bit and going way too fast on your test. These questions could be very easy for you in general, but when you're stressed out from final exams, common mistakes happen. And because it's a multiple choice test, we are kind of hoping that you make a common mistake, and that's why we put that answer. I know that sounds really mean, but you just got to be careful. All right, this one is factoring a cubic binomial. It's the difference of two cubes, so the pattern that we're going to be using is a minus b times a squared plus ab plus b squared. We have not determined yet what formulas are going to be on the formula sheet, but I have a feeling this is one of them. So now your job is just to figure out who a and b are. So you take the cube root of each term, ignoring all signs, because that's part of the formula. So the cube root of this first term is x, and the cube root of 27 is a 3. So plugging in everything where it goes, we get x minus 3, and then x squared plus 3 times x, plus 3 squared, which is, we're going to write as a 9, of course. I like the cubic pattern because you don't have to do any extra work ever. Once you fill in the numbers, you're good. All right, moving over to number 10. This is a vocab question. The degree is the highest exponent. So when I look at this question, I see the highest exponent is a 4, so this is a degree 4. And behavior. You won't be filling it in, you'll be selecting the proper one on a multiple choice test. So this is kind of a dyslexic's worst nightmare though, because if you're looking at an answer and it looks right to you, if you're anything like me, they all kind of look right to you, so you got to really focus and concentrate. We know that end behavior is always referring to the left and the right end behavior. So when I graph this on my calculator, if I realize it's an even power with a positive coefficient, the ends are going to do this. They're both going to go up. So since both ends go up, both of these are going up to positive infinity. So hopefully I am importing this properly, but when I first recorded this video, I had a whole set of problems that got left off because they were hidden. Alright, so the properties of inverses, number 5 on the review packet. There's a few of them at the top of section 6.7 notes where we discuss inverses, but a major one is that the x and y switch. And then another property, because the x and y are going to reverse, that means the domain and range switch. Or reverse, however you want to say that. Domain becomes the range, range becomes the domain. Another property is that inverses are reflections across the line y equals x. And then another property that we discussed kind of after the fact was that if the original function passes the horizontal line test, then the inverse is a function. The reason for that, remember, was if the original passes the horizontal line test, that means the inverse would pass the vertical line test, and that's why it's a function. Alright, so be ready to be able to come up with any of those as being true properties of inverses, or maybe multiple ones. Alright, this part here says the complete factorization of this polynomial. So a lot of kids recognize this to be the difference of squares pattern, so they factor that into x squared plus 16 and x squared minus 16. But that is not the end of the problem, because you can still factor this component a little more. This is another difference of squares, which factors into x plus 4 times x minus 4. Oops, that's a 4. And then the x squared plus 16 does not factor further, but it is a component to the answer. So the complete factorization would be these 3 binomials right there. An example of a cubic function, well, there's a lot of things you could come up with, guys, but, you know, really boring. 5x to the 3rd power plus 2x. The reason I know that's a cubic function is because if I identify the degree as being 3, that's the definition of a cubic function. Polynomial of degree 3. All right, this next one we're going to need to go to our calculator. And you're going to type this function into y1. And for the sake of time, if you don't mind, I'm just going to kind of skip over this part, but it ends up looking, oh gosh, I think I just graphed it the other day, so I think I'd remember. Something like this, like a weird little wonky W. And it says find the relative minimum value of the function. And then it goes on and it says the y value at the minimum. So you want to find the absolute lowest point in your function, which would be this guy right here. And we're going to find that by using our calc menu. So you're going to go to second trace, which is the calc menu. And then you're going to choose the minimum command. And this is where your calculator asks you to go left and right. Now, I have a bit of a shortcut for you guys. If I'm just looking for the height of this minimum value, your graph on your calculator should be pretty much good enough for you to identify an estimated answer. And it's just below the number of 3 for the y value. So what I would do is I would just graph it and look with my eyes and then go to my answer choices and identify which one is closest to that answer. If there happens to be 2 different that are close to the explanation is, then you are going to have to go through these steps to find the minimum. Just be careful. At the bottom of your screen, it's going to give you an x value and a y value. The x value is how far to the left that point is, and the y value is how far up that point is. So you do not want the x value in that case. You have to make sure you're selecting the y value for your answer choice. And I can guarantee you that I am mean enough that I probably put the value as a choice on the test. All right, so here, the domain of this function, it is an exponential growth with a horizontal asymptote at 0, because it's like plus 0 here. So it looks something like this. Domain, that's a dead giveaway question, right? Negative infinity to infinity for all domain on all exponential functions. The range, however, begins at the horizontal asymptote. So remember, since this one is not shifted up or down any, the horizontal asymptote begins at 0 and goes up to infinity for range. All right, let's see if I can not screw this up for like a 4th time now. I'm going to try to import this into your video. Hopefully this all works out. And the next question that you see on your video is, I don't know, number 20, I think? I don't know. It's really out of order. I apologize. All right, number 20, solving an exponential equation. We have to isolate the base first, so let's subtract to 4. So we have e to the x power equals 19. And then you have to apply a common log or a natural log, but man, a natural log would be brilliant here because instead of just having the x drop down, this actually cancels because natural log and e are inverse functions. So x equals the natural log of 19, which if you type that in your calculator, let's see, I think I did 2.94. Very good question. I like that one. Expanding this logarithm, I have 1, 2, 3 different bases, so we're going to end up with 1, 2, 3 different logs. Usually kids can jump straight to the right answer. This first part is a multiplication question, and then when you're dividing by a, the division one becomes a subtraction. So you might start off with expanding it as log of y squared plus log of z, and then it's minus log of a because of the division. And then the only thing you have to remember at the end is any exponents come down in front of their logarithm. So this is really 2 log y, ignore that, plus log z minus log a. So again, multiple choice question, you're going to be looking for the right answer. Condense, you're going to condense this down to 1 logarithm. Oops, this is a typo. Let's make that a 5. So log base 5 of, let's see, subtraction problem, and then the exponents need to go back up. Leave the negative because that just means it's going to be a division. So this is x to the 7th power being divided by y to the 4th power. All of that inside the logarithm. Sorry about the typo. All right. Logarithms. In order to undo a logarithm function, you need to exponentiate. So the base of a natural log is our number e. So if I raise each side of the equation with an e, this is kind of beautiful because they both end up canceling. So all you have to do is solve the 4x minus 18 equals x plus 3. So 3x equals 21 and x equals 7. That's a nice easy question. I like that. Quotient. That means dividing. So I'm skipping over to 27 here. When we divide polynomials and rational functions like this, we have to actually change this to a multiplication problem by flipping or taking the reciprocal of the fraction that follows the division sign. So x plus 8 is a term. It's not factorable, it's just a term. But this guy, x squared plus 6x minus 16, that's going to factor into, let's see, x plus 8 times x minus 2. And then over, this guy factors into x plus 3 times x minus 2. And it's all one big fraction now, so you're going to do some canceling, but don't get tricked here. The x plus 8s are on the same side of the fraction bar. So the only thing that cancels is the x minus 2. So you're left with x plus 8 times another x plus 8 over x plus 3. It's possible that we would write that as x plus 8 squared over x plus 3, or we could even FOIL that out. I think on the test it's more stuff cancels than that, so you won't have such an issue. This question is kind of a concept question. What is the least common denominator for this question? Well, when I look at my denominators, I see 2 very different denominators. I would need an x plus 3, and I would need an x minus 5. So we're trying to hit home that you understand how to build a common denominator. Now here, x squared minus 16 is in parentheses because you can factor this. This is x plus 4 times x minus 4. So when I go to literally add these together and I think about what my common denominator is going to be, well, I need an x plus 4 and I need an x minus 4. Turns out this fraction's all good to go, but this fraction is missing the x plus 4. So the denominator is all done, all set up. All you need to do is clean up this numerator carefully. So we have 6x plus 1, and then positive 4 distributed is a plus 4x plus 16. And then if I collect all my like terms, what do we get here? 10x plus 17 over x plus 4 times x minus 4. Again, multiple choice questions, which I know everyone thinks they're really easy because they're multiple choice. Sometimes they do benefit you. Like on this question, I would see maybe some benefit from kind of knowing the process and maybe being able to eliminate some of our choices. All right, this question. You deposit your birthday money, 3.5% compounded monthly. How many years until it triples? So this is the question where they don't tell you how much money it is, and that's fine because you can just make something up. So you need to make up a number to put in for the principal. I'm going to use $10. Seems good. And then we're investing at 3.5%, so you have to change it to a decimal, so 0.035 compounded n times, so it'd be monthly here, so 12. And then up in the exponent, that 12 shows up again, and you're supposed to multiply it by how many years, which I don't know, so we're going to call it x. What I would have you guys do next is go to y equals, type this into y1, and then go look at your table, and you're going to look for when the money triples. So if we invested $10, I'm going to be looking for $30. And it comes out, I think it's between, it's about 31 years. Okay. So, and that's the way the answer is going to look on your question. It'll say like between so many and so many years, or about 5 years, or whatever the answer is. I don't know. All right. What are the excluded values? It's a concept that was on our post-test. Remember, this factors into x plus 5 times x minus 5. So excluded values are things that would give me a 0 in my denominator. So x cannot be positive 5 or negative 5. Those are the two things I can't have. This time, I want you to solve this rational equation. Most kids look at this question and they just cross multiply, which is probably what y'all should do. So let's go ahead and do that. Oh, let's see here. We have 5x minus 5 on this diagonal equals 6x plus 12. And then we solve. So let's see, I'm going to subtract 5x. How about I subtract this 12 while I'm at it? Watch your signs here, though. This is a negative 17 equals x, which is my answer. All right. This is one of those smush problems. There's no factoring, this is the good news, but you do have to smush this back together. So this is a 32 x to the 6th y to the 6th over 6 y, oops, I should put the x first, x to the negative 2 y to the 7th. So as far as how you simplify this, this is kind of up to you. I would math enter this coefficient, which gives me, this coefficient gives me 16/3. Which, multiple choice question, so I'd probably start crossing off things that don't give me 16/3. And then, careful here, it's x to the 6th over x to the negative 2. You can either move the 2 up to the top, or you could subtract 6 minus negative 2, which is really 6 plus 2, so that's x to the 8th power. And then for the y is y to the 6th over y to the 7th. That would be y to the 1st, but it's going to be on the denominator. So, you're going to be looking for that answer if it was multiple choice. All right, 26. This time we need to simplify, and these parentheses indicate that you're going to factor. So x minus 7 times x plus 2 is how we're going to factor that numerator, and then x plus 7 times x minus 7. This is one of the questions that I changed from the original document, so if you're looking from another teacher, you might have a different question here. All right, x plus 2 over x plus 7. Nothing else cancels. These x's do not cancel, because remember, this is a number and this is a number. All right, here we're solving another rational equation. This time I can't cross multiply, but I do want to use the LCM. So if I look at my denominators, this is a pretty easy LCM question. It's just x plus 5. And when you distribute that into every single fraction, man, we were really nice to you on this question. This first fraction, notice the x plus 5s are going to cancel. You're just going to have 3x. This next question, nothing cancels, so you're still going to have to take 6 and multiply it by x plus 5. And then on the last fraction, the x plus 5s are going to cancel again, and all you have is 4. So we have, let's see, 3x plus 6x plus 30 equals 4. My work's going to travel up to the top here because I'm out of room. So we have 9x, and I'm going to subtract the 30 over. So 4 minus 30 is negative 26. And these answers don't always come up pretty, so don't panic. Negative 26 over 9 works for me. All right. Converting radians to degrees. Again, I don't know what's on the formula sheet yet. This may or may not be on there, so I haven't talked to my counterpart yet. All right, pi over 180 or 180 over pi. You got to remember that pi's have to cancel in this case, so you're going to want the pi in the denominator because, well, look at that. The pi's are now going to cross cancel, and you're going to type this in your calculator, 3/4 times 180, and you're going to get 135 degrees. You can also do 3 times 180 as long as you divide by 4 at some point in your math, okay? Some of you weren't sure how to type that on your calculator last time, and that's actually the whole point of the question, so make sure you know. Find the period. This is a vocab question. Remember, period is 2 pi divided by b. So when I look through my question, b is the number that's inside our trig function in front of the variable. So b is 4. So setting that up, we have 2 pi divided by 4, better known as, this is half, right? So pi over 2. Find the amplitude. So amplitude is the absolute value of the number that's in front of your cosine or sine function. So the amplitude is 5. And then just what you're going to do on the test is you're going to choose which one has a vertical shift or of 4 or -5 or whatever we ask. So here you're just going to write an example. So we have a lot of options. I'm just going to say like sine of theta plus 4. It could be anything as long as there's a plus 4 on the back end here. All right, this is a nice little application question for trig, and they gave you the function, and they want to know how many seconds elapse for one cycle. Well, that's just a really fancy way of saying what is the period, because how many seconds for one cycle is period length. So same formula for period, 2 pi over b. So I look at my function. This time b is a pi, so the pi's are going to cancel out, and you get 2 seconds. A real-world question should have a real-world answer. Keep that in mind when you're answering that question. All right, little probability for you. We're rolling a 6-sided die with numbers labeled 1 through 6, like a normal die. And what's the probability of it being odd? Well, remember, you can either get these answers, and odd would be 1, 3, and 5. So that would be 3 out of the 6 outcomes, or 1/2. All right, researchers from a group of, give one group the new cold medicine, and then compare it to another group that takes no medicine. So the group that has no medicine, we call the, not the control group. Make sure I was answering that right. And then the other group, the group that is given the medicine, is called the treatment group. The treatment group versus the control group, sometimes the control group is given a placebo, but they're still control because there's no actual medicine, no changes being made to them. And then vocab word here, if you have a sample that is very different from the population, that means you are biased. Your sampling is biased. Remember that keyword, okay? And then we have that probability question with the chart. I changed some things on this chart from the original document. So if you're from another teacher, make sure you have these numbers. Probability of female and junior. Well, I remember that ands and ors do have something in common. The denominators are going to be out of the entire total. So both of these questions are going to start with 69 as their denominator. But the difference is when it's and, female and junior, you go to your chart and you find that one number that's both female and junior. That would be these ladies right here. So 15 out of 69, which does reduce when you math enter that to 5 out of 23. If it's a reducible fraction on a multiple choice test, it is very likely that they have been reduced or written as a decimal or a percentage. So make sure that you're looking for equivalent answers even though your answer might not be there. Or, a little different, you're going to have to figure out female and then junior, and then you're going to have to subtract the overlap, right? So total female is 39, total junior is 26. So we start with 39 plus 26, but then we have to subtract the female and juniors. These overlap parts are right here, which is those 15 girls from the first problem. And when we get that on our calculator, you get a 50 out of 69, which does not reduce. Female given junior, this is the one where we encourage you guys to highlight. So I'm going to erase all my, oops, that's not an eraser. I'm going to erase all my other marks. When it says given junior, that means you're only allowed to look at the junior data right here. So female given junior would be 15 out of the 26. All right, and I think that's the end. So good luck on your final exams, everybody, and you can always go back and rewatch lessons. I can give you tons of extra samples of problems. We can sit after school, keep doing problems over and over again, whatever you need, okay? This is going to be a little less than half of your final exam score, so good luck. All right, so fun fact, your review was missing 6 questions. So let's call the first one number 14. You might notice your review packet skipped from number 13 to 20. This is why. So number 14 is going to ask you to identify when you have an exponential growth or an exponential decay function. So a little reminder, when you have an exponential function in general, it takes on that form, and depending on what the base is, you'll be able to tell whether you have growth or decay. So if the base is greater than 1, then you have growth. And if the base is less than 1, then you have decay. So as some examples you might have seen before in your other testing, y equals 4 times 2/3 to the x power. That would be exponential decay because the base is 2/3, which is less than 1. So make sure you're looking at the base number and not anything else in the function. All right, moving along to what we're going to call number 15. What would have been number 15 if we had one. It's going to be a question involving this formula, which is PERT. This is given to you on your test. You do not have to memorize it, but it's going to say that you invest, let's do $2,000 at a 4% interest rate for 5 years. They're going to ask you for the balance of your account. So this is not going to be a question that you have to do in your y equals or on your table. This is just a compute in the home screen kind of a question. So in your home screen, we're going to type 2,000 as your principal. Oops, 1,000. And then you're going to use the button E, and I would suggest you use the button that's above natural logarithm, the one that brings up the exponent for you. Because since you're up in the exponent, now you can go ahead and type your interest rate times t. Now be careful, the interest rate here is 0.04 because you got to divide that by 100. So 0.04. And then times the number of years, so there's t, so times 5. I'm going to need a little assistance from my 4th hour friends. Can you guys type this in your home screen and tell me what you get? To the nearest cent, please. Read it off, dear. 2000.81. Thank you. All right. Makes sense. All right, so again, no memorization of that formula. You just have to know where to go on your calculator and how to type everything in. And then there's a question. It looks a lot like a question from your post-test, actually. We'll call it 16. But you're going to be given this formula, y equals a 1 plus r to the t power. Oh my gosh. And remember the question in your post-test that was about like a hotel room and it cost a certain amount in 1980, and then you were supposed to write a model that tells you how much it would cost in like 2020. So it's a very similar question. It's probably got some other context to it, but remember you're going to put your initial amount here. So let's say the initial amount was $50. And then 1 plus the interest rate. So if the interest rate is 4.2%, remember to write that as a decimal, 0.042. And then this time, they're going to tell you how much time goes by. So they're going to say something like 1970 is where your data started, and they want you to project all the way out to 2020. So how much time has gone by in this question if it's from 1970 to 2020? That would be 50 years. So that's what they're going to have you put in place of the t up here. So some help from my 4th hour friends here. Round to the nearest cent again. What'd you get? $191? 391.16. All right, very good. All right. We'll call it 17. There's a question where it says they want you to solve this equation. So log base 5 of 125 equals x. So, there's a couple of different ways we could solve this, because we know when we solve logarithm equations that we're supposed to exponentiate. You could exponentiate this. The other thing is, I think on your formula sheet, is there a change of base kind of a formula where it says log converted to exponential form?
Yeah.
Okay, I might suggest you guys do this question that way. So it says base to the answer power equals this number. So that's us taking a logarithm equation and rewriting it in an exponential equation. It's the same idea as exponentiating, so if that's how you want to do this question, that's fine. The reason I don't really have to do any more work is because this is a really obvious question when you look at the setup. 5 to what power gives you 125? I think it's 3. 5 to the third power is 125. So if you chose to exponentiate with a 5, like we always do, you're still going to get that same setup. The 5 to the log base 5 will cancel, and you'll get 125 equals 5 to the x. And then from then on, it's an obvious answer. You just have to look at the choices. All right, there's a follow-up question to that that's the opposite. It's going to give you a logarithmic formula, and they want you to rewrite it in exponential form. Well, I guess it's not opposite. It's exactly the same thing. What am I talking about? So how about log base 3 of x minus 1 equals 4? And they're going to say rewrite this in exponential form. So here I want you to concentrate on using that formula. Again, if you were a big fan of exponentiation, that formula is what happens when you exponentiate. So go ahead and think of it that way. But what you do is you find the base, and then it's raised to this answer power equals x minus 1. And that would be all you have to do to that question. You don't even have to solve it because they just want you to rewrite it in the other formula. So if you want to attack that as an exponentiation, you go right ahead. All right, and we got one more question. We'll call it 19. And it comes back to the idea of what is the inverse function to an exponential? So, it's a log, yeah. So if this is my exponential function, his inverse is a logarithm of the same base. Remember that little rule? So good thing we're reviewing, huh? So I'm going to give you a different question, and you tell me what the inverse is. So y equals 5 to the x power. So that's an exponential of base 5. So what would his inverse be? A logarithm of base 5. Very good. Ta-da! So that should be a really nice question as long as you remember whose inverse is. All right, I'm going to stop this video, and hopefully we're going to import it correctly into the previous video. Yeah. Sorry if I just messed everything up.